Thank you so much for your participation.
And very nice that you're organizing it.
No, thank you so much.
Yeah.
We really appreciate.
Yeah, it's all very good. Because there has to be some scientific activity.
Right.
Though there is a pandemic, but this is the best way to,
we
get
can
people
communicate.
Yes, and get people enlightened about the latest technology status, isn't
Very
it?
right.
Yeah. But one thing is that the regulatory system needs strengthening, needs attention.
No, we are doing our best. Good morning, Dr. William Garg.
Good morning to all.
How are you?
Good morning, sir. This is Rajiv.
Very good, very good. How are our friends from Apari and India?
All are fine here. Thank you so much.
Oh, Rajiv Barsht is there.
Good morning, sir. Good morning, sir. How are you, sir?
Kiran Sharma.
Yeah.
Morning, Khun Mei. How are you?
Morning, Swadika. Very good. Sorry, I went to the long one. Dr. William, we met in the Philippines.
Hi, Swadika.
Swadika.
Yeah.
Yeah, I see Dr. Okjai Koo, one of the key speaker here also.
Yeah.
Morning,
Hi.
Dr. Koo.
Good morning. How are you? Yeah.
All fine. Dr. Kashikawa also has joined. Masahi Kashikawa.
Hi. Thank you.
Morning,
so
and
much.
thank you for joining.
Thanks for inviting me.
So shall we start, sir?
Yes.
I think so. We can start. It's right 1:30 here where I am. Yeah, it should be 10:30 in Bangkok. Yeah, right. We can.
Thank you so much, sir. We will begin the deliberations of this webinar. I am Dr. Vibha Ahuja. I am from Biotech Consortium India Limited and will be with you throughout the webinar coordinating this. A very good morning to all and a very warm welcome for the third webinar on enabling policies for genome editing in agriculture. As you are all aware, this is our part of our webinar series on the applications of gene editing for sustainable agriculture and food security. So I'd just like to give a very brief background before giving it over to Dr. Khetarpal and their respective chair. This webinar is being organized by the Asia Pacific Association of Agriculture Research Institutions, briefly mentioned as APARI, based in Bangkok, Korea Biosafety Clearinghouse, which is based in Seoul, South Korea, and Biotech Consortium India Limited, New Delhi, India. That's my organization. Very briefly, I'd like to recap, since we have the respected chair for the third webinar here and the new speakers, just to give a brief recap of what is the objective of this whole series and what all we have done in the webinar 1 and 2. So just to give a brief background, this webinar series and the preparation of a resource document has been conceptualized as a follow-up of earlier initiatives in the Asia Pacific regions, like the Second Asia Forum on Genome Editing held in Korea, followed by a regional expert consultation on gene editing and regulation in ICRISAT and APARI undertaken jointly in Hyderabad. Subsequently, the 1CG webinar series has also been held, and similar observations were noted that there is a need for science-based, predictable, proportionate regulations to encourage innovations in the gene editing. And it's very essential that we, particularly in the Asia Pacific region, are able to harmonize the approaches for collaborations in research capacity, development, regulation, and trade. So keeping all that in view, we all have led by APARI, this initiative has been conceptualized, where we are targeting a development of a resource document on application of gene editing in sustainable agriculture and food security in Asia Pacific region. And this document is being prepared with an objective to provide governments and other interested stakeholders with information needed to inform the policy development particularly the regulations and other trade-related issues on the gene-edited plants. So with this background, APARI had constituted a very high-level steering committee, and I wish to thank the steering committee for helping us plan these activities, who suggested that prior to the resource document, let's have a webinar series wherein we get the views on very important topics, which would be very useful for our esteemed authors to come out with a resource document for use in the region. So we have a steering committee which from multiple representatives, senior regulators and scientists from the Asia Pacific region countries. We have Dr. Norvati Adnan, who is the Director of Biosafety in Malaysia, Dr. Florida Carino, who is very active in Philippines, the member of the Regulatory Committee, Dr. Jang, who is the Korea BCH focal point from KBCH, Dr. Ryo Osawa from Japan, he is from University of Tsukuba, but are very, very actively involved in the regulatory systems. We have Dr. Heidi Michel, who is from the Office of Gene Technology Regulator in Australia, Dr. Roland from the World Vegetable Center, who would also be sharing views this morning, Dr. Kiran Sharma, who is the Deputy Director General of ICRISAT, as ICRISAT has been very, very actively involved in this activity, and Professor Xuanyang Hu, who is from the National Taiwan University. All this, we have international experts from the US, Dr. Marvin McLean, Director of Global Strategy, Regulatory and Public Affairs in Bill and Melinda Gates Agriculture Innovations Institute. So this is our esteemed steering committee which has been guiding us through, and I would like to express my heartfelt thanks to them for planning in this activity. I won't take too much of time, but just to brief you that there has been immense interest in this webinar series, and we were ourselves, very pleasantly surprised at the number of registrations that we got. Till today, we have got more than 2,500 registrants from almost not only in the Asia Pacific region, but almost 70 countries worldwide. The number of people who actually joined the first two webinars were about 700 each. The first webinar was on the applications. We understood the potential of gene editing and its relevance in the Asia Pacific region. And the second webinar focused more on the regulatory and the other issues. But today we have a very important aspect of it, which is the one which helps bring gene editing technology to the use of the farmers. And this is the enabling policies for genome editing in agriculture. We have none other than Dr. William Dar, who is the Secretary of the Department of Agriculture, Philippines, to chair this webinar. I will give a brief introduction after Dr. Khetarpal informs you more about what APARI does and why this initiative. Over to you, Dr. Khetarpal. I invite Dr. Khetarpal, is the Executive Secretary of APARI and highly supportive of this initiative to take forward these innovative technologies for the Asia Pacific region. Sir.
Thank you, Dr. Viva. Good morning, good afternoon, everyone. I welcome you all once again to this very important webinar. And my special welcome to Dr. William Dar, who is the Secretary of Department of Agriculture in Philippines. And many of you, or some of you may be knowing, it is not where he is right now. I am welcoming him. He has been a good member of APARI family. In the 90s, he had been the chairman of the APARI Executive Committee twice, and also when he was serving for PCART, and later when he became Director General ICRISAT, he was again a chairman somewhere around 2007-8, if I can remember. He has a lot of contribution, and he has been a staunch supporter of biotechnology and our program on Asia Pacific Consortium of Agricultural Biotechnology and Bioresources. So welcome, special welcome to you, Dr. Dar, and welcome to each and every one of you. Well, as Dr. Vibha mentioned, it is the last one in the series of webinar where we want to culminate to a point where we discuss on the enabling policies for gene editing in agriculture, and which will be a part of a resource document we are developing. So the inputs of all of you, all the panelists, all the speakers will be very crucial. we really want to have a clear stand or a policy positioning in Asia and Pacific on genome editing, which is a very important subject area nowadays. Some of you who may be knowing about APARI, but many may not be familiar, I may like to say that APARI is a membership-based organization established way back in 1990 under the aegis of FAO of United Nations, and has a mission of strengthening agri-food research and innovation in the Asia-Pacific region for sustainable development. Over the last 4 to 5 years, there has been a lot of transformation in APARI's working, and now we have our strategic plan implementation, which we are implementing through support from FAO, WTO, ACIAR, European Union, USDA, Council of Agriculture, and some other donor agencies in the area of bioresources, biotechnology, risk mitigation, inclusive development, and policy and advocacy. So we do have programs on knowledge management, capacity building, foresight and visioning, and so on. The challenges, if you look at in the Asia Pacific, are plenty in agriculture. We are struggling hard to achieve sustainable development goals of the United Nations, but lacking far behind as per recent report from United Nations Economic Social Commission of Asia and Pacific, and not even halfway through of achieving the targets of today. COVID-19 has compounded this situation. Asia Pacific is having more than 60% of the population of the world. And you can imagine the kind of challenges which are growing in abundance in order to feed the growing population. Now, in the field of biotechnology, there have been challenges all through, right from the investment up to the application, and also some complications of the technology with the hostile public backlash in European Union especially, and other parts of the world also, on GM crops due to certain ethical considerations from consumers' angle. In the wake of that, gene editing has come as a boom. It has brought a lot of enthusiasm, but at the same time, a lot of challenges on the regulatory side. There have been two important events. One was the second Asia Forum on Genome Editing held at Gangneung, Korea, organized by Korean Biosafety Clearinghouse in 2018. And there was one organized by APARI in partnership with ICRISAT and other organizations, a regional expert consultation on gene editing and its regulation. As a fallout of these important consultations, the recommendation was more on the enabling policy environment to continue the good work we all are doing on genome editing. Well, APARI now is committed to have a special focus on policies and innovation related aspects as we are moving in that direction, and not to do the same kind of a thing we had been doing before or many others are doing. We want to focus more on policies and more on innovation in all the activities that we are doing through capacity building and knowledge management. We have thus initiated the exercise of the development of a comprehensive resource document, which Dr. Vibha rightly highlighted, on application of gene editing in sustainable agriculture and food security in Asia Pacific region. So this webinar is a part of the series of the webinar where we are trying to get good information on the application of gene editing in agriculture, in improving food and nutrition security, and also the commercialization and investment part so that we can go from lab to land with gene edited plants. And now finally on the enabling policies for genome editing in agriculture, which is the ultimate output which we want from the whole exercise. So as I mentioned before, Dr. William Durr will be the moderator with his long-standing experience. I'm sure we are going to have a very interesting session with presentations by Dr. Kangokwan Choi from EPSA, Bangkok, on need for harmonized policies, on research, utilization, and genome edited plant, and also by Mr. Fabrice Matai, who will be speaking more on understanding the IPR, intellectual property right landscape of gene editing. Then we have the 4 panelists, as was highlighted, Dr. Roland, Dr. Ogjai Koo, Dr. Masahi, and I will also be one of the panelists. And so we would like to capture as much as possible from this webinar to make sure that the policy positioning document, what we call the resource document on genome editing regulations and policies for Asia Pacific, which we are trying to bring out through collective action with the global and the regional experts on the subject. And we will be able to do a good job with all the support from all of you and all the inputs from all of you. At the end, I would like to profusely acknowledge the support of the Korean Biosafety Clearinghouse, both technical and financial, and of BCIL, Biotechnology Consortium India Limited, for collaborating actively with APARI, and to all the participants who are now involved in the webinar. Again, special thanks to all the members of our steering committee who carved the roadmap, who carved a clear roadmap of webinar series for initiating the exercise of reviewing the whole aspects of genome editing, whereby we can come to an enabling policy positioning place where we can really make Asia Pacific benefit with the application of biotechnology, with the harmonization of the regulations. Eventually, we would see that that would be useful both from the angle of food security and also from the angle of international trade, which is jeopardized under the WTO regime because of many issues in the technical issues or risk factors which are supposed to be associated with that technology. So with this, I would like to thank you all once again for participation, and over to you, Dr. Vibha. Dr. Vibha, you are on mute.
Dr. Vibha, unmute yourself, please.
Dr. Vibha, you are on mute.
Sorry, sir, sorry. I would like to introduce Dr. William Durr, our chair for the webinar today. Dr. William D. Durr is serving as the second time as the Secretary of the Department of Agriculture, Government of Philippines. We in India have a very special association with Dr. Durr, as he has been as he led the ICRISAT here in India for almost 3 consecutive 5-year terms, that is from 2000 to 2014. His extensive research and professional experience includes crop management, farming systems, development, technology sharing and upscaling. Several initiatives, very difficult to explain in this very short time, but we have circulated a detailed information about Dr. Durr to all the participants. Very briefly, he has received 8 honorary doctorate degrees in various fields from several state universities and colleges. In December 2016, President of the Philippines honored Dr. Durr with the 2016 Outstanding Filipino Award for his exemplary achievements and selfless dedication to his profession that made significant contribution to the betterment of the countrymen and to his country as a whole. His leadership is guided by a solid and enunciated principles of food security and has bestowed laurels such as the Lifetime Achievers Award during the Asia Leaders Awards, also Lifetime Contributor Awards and of course the Presidential Award by the University of Philippines Alumni Association, where he started his career. Dr. William Dar is a champion of the poor, especially the small farmers, fisherfolks, and agripreneurs, as is from the various initiatives taken through his career. And sir, a very warm welcome to you, and thank you so much for sparing time this morning. We really look forward to your hearing your views, sir. Over to you, Dr. Dar.
Thank you, Dr. Biba Ahoja, for the very kind introduction. Excellencies, distinguished participants, friends, ladies and gentlemen, good morning. First of all, allow me to express my gratitude and appreciation to all of you for your warm welcome. I am happy to be back with APARI, with this engagement to you today as chair of this webinar. And I want to express my gratitude and appreciation to all of you for your warm welcome. I want to thank Dr. Rabi Kitarpal, the Executive Secretary of the Asia Pacific Association of Agricultural Research Institutions, for the invitation to chair this webinar. I'm pleased to join, but before any further, let me also thank Dr. Kiran Sharma for initiating this invitation for me to chair this webinar today. I'm pleased to join this gathering of some of the world's brightest minds in gene editing technology, agriculture, and policy advocates for food security and nutrition. Of course, I see here during this webinar a good number of ICRISAT scientists whom I have worked with, in about 15 years of stay at ICRISAT, like Dr. Rajiv Barsne and others. We are here to harness what is most special about the Asia Pacific, that is our will to innovate, our ability to dream and experiment, and to think and try new things. For many in the region, the challenges of development are deep, difficult, and persistent. Poverty, technological arrears, and waste management systems, leaving much to be desired. The growing populations of the Asia-Pacific region are also putting a strain on natural resources, such as land and water. There is thus a common motivation for all of us to turn to our neighbors for cooperative solutions. In the Philippines, as in many other countries, we consider our universities and colleges as wellsprings for learning and innovation in agriculture and nutrition. For this reason, we at the Philippines Department of Agriculture tap those excelling in the field of research for development instead of research and development. Our point is that research must not end in publications alone. A scrap of paper in some science journal is useless in the field where actual hard work matters and concrete, grounded insights are gathered. Our policy is that research for development must ultimately deliver actual innovative results that can be utilized and integrated into the value chain and food systems. Research outputs should help farmers increase their productivity, attain efficient operations, and double or triple their incomes. Research must be directed towards ending poverty and its attendant ills, foremost of which is hunger. This gathering, therefore, should induct an entirely new era of agricultural progress. In particular, Our joint efforts should culminate down the line into creating more jobs, noble industries, and normalize sustainable, life-giving technologies created right here in the Asia-Pacific region. We always celebrate science and innovation, but we are much less enthusiastic and vigorous in investing in them, and such hesitation retards creative thinking in research for development. Here is where government policies for agriculture will matter most for our shared future. Last year, for instance, the National Committee on Biosafety of the Philippines issued a policy labeling products of plant breeding innovations or new breeding techniques, including gene editing, as non-GM if they do not contain a novel combination of genetic material. These products are now exempt from our existing rules and regulations for GM plant and plant products. We have formulated guidelines for this policy. They are still subject to various stakeholder consultations in the coming months, but we hope to issue the finalized guidelines within the year. We believe this is crucial in ensuring effective and efficient regulation of plant breeding innovations or new breeding techniques while encouraging research into gene editing technologies to improve and strengthen Philippine agriculture. It may interest you to know as well that we have issued the appropriate policies to commercialize the production of golden rice nationwide. Thereafter, we will produce in large scale, particularly in provinces with vitamin A deficiencies. So the consequences of such policies are many and far-reaching, as we have seen in countries like Argentina, which employs product-specific, risk-based approaches. Their research for development has become more diversified. We need to ease up the policy environment to enable the fast adoption of technologies such as gene editing to have their place in the international trade of plants and food unobstructed. From pest resistance as the conventional focus, public and private sector technology developers are now investing in research projects for producing other desirable traits in crops. The Philippine government sees such combinations of sound and realistic policy and know-how as invaluable tools in our efforts to mitigate and minimize the effects of climate change on food security. We realize, too, that gene editing technology is universal. Its potentials, if wisely employed, provide the adaptive means by which all humanity can realize a full and abundant life despite global and natural challenges to our circumstances. It could prove transformative in our ongoing fight against world hunger and our campaign towards the achievement of sustainable development goals. The global scale of current challenges amid the COVID-19 pandemic demands an international pooling of knowledge and effort. The coordination of policies within the Asia-Pacific region is essential for collaboration in research, capacity development, regulation, and trade. And APARI can be that platform. We need to strengthen the science in our bloc to amplify our voice and campaign for innovation in more holistic and high-level scientific consortia and geopolitics. That makes gatherings such as this webinar important for many nations in the developing world, where the benefits of science-driven innovation are now finding a place in the homes of people who will mostly benefit. We hope that out of the suggestions and ideas and proposals that we make in this gathering today, we can find ways to extend the benefits of new gene editing technologies across the agriculture sectors of our nations. We believe this to be an excellent opportunity to foster the trust and mutual understanding essential for the entire Asia-Pacific region to prosper. Once again, on behalf of the Filipino people and our beloved President, Rodrigo Roa Duterte, thank you for this rare privilege and opportunity. May this gathering activate our imaginations more on what crop science can achieve. Thank you.
Thank you so much, Dr. Dar, for such encouraging words and bringing in clarity in giving us the guidance to move forward. We will definitely work towards that. The research in the Asia-Pacific region does not remain to the publication, but reaches to the farmers and guided by the components which you said, research capacity building, trade and regulations, all need to be dealt with. Today's, as I mentioned in the beginning, and also said by Dr. Khetarpal, we are going to discuss, we've had a discussion on the first two parts in the two webinars, but today the focus is on the trade, intellectual property rights, which is one of the major components, and also a discussion on the public perception and communication. So my first presenter today is Dr. May Chorjoy. She is the Executive Director of the Asia and Pacific Seed Association, APSA in Thailand. Dr. May holds a PhD in biotechnology from Mahidol University, Bangkok. She has been working in the multinational seed companies to manage the quality program for Asia Pacific region before joining APSA. And she's leading this APSA, which is the main focus of this is on seed sector development in the Asia Pacific region through the activities that can create awareness on the IPR, plant variety protection, trading of quality seeds, and also the public and private partnerships for policy dialogue on all these issues. She would be speaking today on need for harmonized policies on research, utilization, and trade of genome-edited plants. Welcome, Dr. May, and thank you for sparing time. Over to you. You can share your slides.
Good morning, all the participants. Good morning, Dr. Khetarpal, Dr. Vipa, and our Mr. Chair, Dr. William Dar. So first of all, I just would like to share a little bit who is Asia Pacific Seed Association, and it is just a great program organized by APARI. I think this is very right moment to put the webinar series for gene editing for, not only in our region, but also for the rest of the world. And what Dr. William Dar has said for this session is totally correct and right approach. And, from APSA, we would like to congratulate also the Philippines as, the way you lead the innovation in the agriculture with the golden rice also approval to be the commercialization. So, okay, so Asia Pacific Seed Association, or in short, you can call APSA. So APSA is a member-based organization similar to APARI. However, we are representing mainly seed sector or private sector. So in our database, we cover 29 countries inside Asia Pacific and also around 24 countries outside Asian Pacific region. So we have our members who join directly as the members from the seed companies, and 50% of all the members, actually they are having the integrated seed company. So meaning that they also do the R&D facility by themselves. Beside that, we also have 24 seed associations. Most of them are national seed associations and also non-profit organizations who work or contribute in agriculture join as a member. Beside that, we have around 10 government agencies from 10 countries join in our association. So why we need to come together and also work with our stakeholders on this, because seed is very important and very crucial. Later on, you will see also how we work together and what kind of, especially on the gene editing as the new breeding tool, we would like to be able to put from research to the hangars, as Dr. William has said in his presentation. So the key strategic plan, you can see here, this is all the things that we need to facilitate the movement of seed around the world. So first is intellectual property rights, biodiversity and genetic resources, phytosanitary standard, innovation in agriculture, which we are going to discuss today. Last is public and private partnership. And this is our key stakeholders. You can see here that the way we work is also thank you. So the way we work is we collaborate with the international seed organizations. You can see here we also collaborate mainly on the breeding program, especially to bring research to the hangars with World Vegetable Center. And of course, APARI, Life Asia, and all the stakeholders are working with us when we do on, especially on the capacity building and policy advocacy. All right, for my presentation today, so the topic is need for harmonized policies on research utilization and trade of genome edited plants. So before I would just like to share all of you about what is seed trade and how research, seed trade, seed production, and policy are linked together, and what it's going to be for the world if the policy are not harmonized. Okay, I think I would like just to start from just sharing to you all challenges ahead of us, or even now we are facing with the COVID-19 situation. I think we are aware of the food security more than ever before, and thinking about 2030 up to 2050, you can see that there are so many campaigns now today to create the awareness about the food security. And you can see also like UN Food System Summit also focus on this, and FAO also launched a program called International Year of Fruits and Vegetables, just to share the importance of nutrition for fruits and vegetables, especially for the poverty and also the hungers. And moving from here to 2050, many things need to be changed to ensure that farmers get the right demand of the crops, and also the consumers get the right demand of food. Okay, now this is the picture that happened now today. You can see still here totally different way of the fruits or vegetables that are offered in the market, right? So we still see some countries that they are very lack of the nutrition, like they still face malnutrition for the people, while some countries they have very high quality of the products in the market. So this is now, right? And what about the future? And how can we help on this if we know that the future, there's so many challenges ahead of us? Yeah, so we demand for food security and high quality of food. All right, if you see here, yeah, some already solutions has been started or introduced to the market. I think you have seen the webinar presented by Dr. Hiroshi, the one who discovered the GABA, high GABA tomato. Another one is RNAi technology. This one I got presentation from CropLife Asia. The Golden Lights, this one just presented by Dr. Dar. So you think that are these products a solution to overcome our challenges? Just think for yourself. All right, so we already see how, you just go to the market for those who are not in the seed sector, right? So you just go to the market, you get what you want and put on the plate, and that's how you feed the family. And if you look into the total global food system, this is the complication. This is the complexity that we are having now today. And guess where we are for the seeds and technology in agriculture? We are in the input, right? So we are here. We are here, see. You can see that as we are here, we are the starting point of the input. This is very crucial that we really have a good research capacity and also a very good way to unlock the policy to be able to use the tools that we can feed more or meet more expectation or demand of the consumers at the end. You can see here that such a complex in the global food system. And if you look into here in the bottom of the infographic, supply farming and food demand. In order to meet each other, you need to emphasize on global trade and transport. Okay, so I just put here, unlock the power of plant breeding tools to feed the world. So you can see, I think here is, you can think for yourself even, the impact of policy that each country perhaps that if there is no, there's no harmonization in terms of the policy, what would happen? All right, so next, I would like just to take you to the work that the seed sector has been done or they're still doing currently, and what is the importance of the breeding stage or the breeders, all right? So at the breeding stage, there's, this stage can be done by public and private sectors. And right now, there are so many research has been done by public sectors also, you can find in many publications, but in the real world, the rate of the publication become to the commercialization fairly low percentage. Okay, so in this state, it's very crucial for the seed company to be able to meet the expectation of consumers and farmers. You can see here at this stage, you need good genetic resources. You need, if you don't have your facility, you need to work with the public sector. You need to have good breeding tools or techniques, and you need to be able to understand the technique that you use, whether or not it can go to the market, right? You need to understand the diseases. There are so many things that one breeder needs to understand. And the expectation from consumers and farmers now today, what they are looking for when for the future products, let's say. Of course, number one is disease resistant, drought tolerance, improved process quality, long shelf life, so on and so forth, right? So another thing is I found this study, and I think that this is very interesting. This study, they collect the information from 114 responders, the age from 45 to 65 years, and it's just from different regions. So only 6% from Asia, and both from scientists and non-scientists. Just ask the expert opinions about what do you think about genetic editing crops versus genetic modified and conventional. And of the result here, you can see strongly agree, very high percentage that they believe that gene editing can help to cope with can be a good technique to use for improved resistance to disease, increased drought tolerance, improved processing qualities, longer shelf life and storability, high yields, better nutrition, improved climate change resilience, which is very important, which is a focus right now, and also increased food security. So there is already a trust or a belief in the tool that this would help breeders work faster to meet the demand or expectation of the farmers and consumers. Okay, this is just to show you again that, as I mentioned, that there are so many research or publications done on CRISPR-Cas. This is just only in tomato. You can see here, and I put also the reference here. There are so many techniques that they use, but now you can see that the rate of using this technique or CRISPR-Cas9 is becoming very popular because they see the usefulness of this tool. Okay. Another publication also, this one is very interesting that the experts get together and they call a World Cafe. You can check this publication and read this also. The view is very interesting. So you can see here that they also put the timeline for the product that has been non-regulated status, or it means that it's already released to the consumer in the USA. So you can see, but these are using the CRISPR-Cas9 technique. Herbicide-resistant canola, high-yield waxy corn, soybean with reduced trans fat, non-browning mushroom, right? And you can see here, this is the rate of the publication that has been done by using different technique. You can see that genome editing is kept going up. That was in 2015, and you can see now, I think I have the data in the next slide. You can see also even more. All right. So when we look into another review also, this is the gathered by Benz and his colleague, and this is just published in 2020. Very interesting. You can see is also show in a way that, you know, how seed sector would move also in the region. So you can see if this technique is properly regulated in the country or in the region. So the number one country that has the highest number of market-oriented genome editing application is China, then USA, Japan, Germany, and France. And you can see here also the by trait application, what kind of traits that they use this technique for the publication or in the crops. So number one is agronomic value and food and feed quality. So meaning that they actually target the nutrition also as well as the demand of the consumers. Okay, that's all the work of the breeders, right? So as I mentioned, so in here you see this is number of publications, and then after this process, in order to get the seeds to be commercialized, there's so many complications or the many processes to ensure that the research can go to the seed company and eventually can be sold to farmers and consumer. All right, okay. So this is the whole process of seed production nowadays. So in seed company, they can have breeding, seed production, seed processing, packaging, distribution. If they have all this function, we call integrated seed company. If they have only like seed production or seed processing, they can do the activity in each state also separately. But very important to understand is that each stage of the seed production can be done in more than one country. So it means that the seed has been moved across countries. Does not need to be only for commercialization purposes. Okay, next, another layer that I want to show you, since you already know that nowadays when we move the seed, there are so many, not only for commercialization, it can be for breeding purpose, it can be for seed conditioning and, you know, so on and so forth, in order to eventually move the final product to the consumer. Okay, so this one is just a glance for you to understand. You can just do not need to read, but just understand by the difference of the color. So this policy development around the world, this one collected by International Seed Federation together with CropLife International. You can see here that there's the country with positive decision, country with no formal decision, but positive direction, country that just start the discussion. I think if you would like to learn more, I encourage all of you to watch the webinar too. I have learned that myself, and I really enjoy the way the experts tell about the difference in each country. Okay, so this is the overall, right? So another layer, okay, in the complication only, I'm talking only about the gene editing too, all right? So this is the different way to create or regulate policy in the country. So this one also, if we divide into what is, which one use product trigger regulation, which one use process trigger regulation. So this publication was published before Japan has done their own policy. So Japan is not mentioned here, but of course, I think everyone knows that Japan use product-based regulation. Okay, more references now today. If you go, you can see and check by yourself, especially the OECD conference on genome editing application in agriculture, implications for health, environment, and regulation. This is a very good review, and also many comments or view from the scientists put also in the publication, which I really encourage that you can explore more on this, and then you understand the difference. And this is just example. This is from the same publication as I mentioned, that the expert or scientists from different nationalities, different countries, they come and discuss together. They call the forum as the World Cafe. This is what scientists has view in terms of how the gene editing should be regulated. So maybe it take time also to understand this graph, but they put everything together into the view. Like here, for example, from left to right here, the red color is like, oh, this should be regulated as GMO. And so if you look into the vertical, so here is called LMO, like under the criteria of LMO, since they have the rDNA, and this is no rDNA. So for example, they use this concept referring to the Cartagena protocol. Right, so here SDN1 can be also classified as LMO, or it can be classified as not LMO, depending on the rDNA, for example. So you can see also this is the view from the scientists. That's why we keep saying that, well, it has to be science-based and also risk-based in order to work on the policy for international level. And political decision might result in some, of course, we call over-regulated, contrary to scientific advice. This is another example. I see that in Webida 2 also we have this pop in the chart as example from the Asia Pacific. This is the, I would not repeat again, just also this is the decision tree, which they decide whether or not it should be gene editing technology should be regulated as GM, or should be regulated as non-GM, or should be the same as the conventional breeding process. This is another example, this one from Japan, whether or not it should be LMO. So here is referring to the Cartagena protocol. And so in Japan, they have their own Japanese Cartagena Act. And in here, this is the decision tree also. Basically, they just, at the end, we need to prove that whether or not it's contained foreign nucleic acids. If not, it's not considered as LMO. Okay, so this is the same publication that they survey 114 responders and ask them again, how do you think the agent should determine where and how new breeding tools will be developed and used in agriculture? And here they put the trust on the national and regional regulations for health and safety. Of course, later they put export markets should also should generate a demand on this, and user consumers. And very interesting that they put the media before the plant breeder, but I think the score is quite similar. So it means that scientists need to talk more. Of course, the media need to start sharing very correct information or science-based information about this technique. Okay. Next, I just would like to show the view or the work that OECD and WTO has already done. For me, is just show that they are aware the importance of the policy on the seed trade for the gene editing product. So in OECD, as I mentioned, so the reports has shown very good and very clear that they get together the stakeholders from many countries, including scientific experts, decision makers, regulators to talk about the policy, and they have so many examples from many countries. You can also search and check on that. And they also mentioned very nice highlight that the different legal system understand their respective regulatory and policy approach to genome editing is very important to minimize the the difference in terms of the policy. From WTO, also similar approach. There are so many countries sign the kind of the statement together. The delegations agreed to engage for the exploration of science-based opportunity for regulatory framework and the avoidance of trade barriers for products derived from genome editing. I think this is very crucial, very important that they are already think about this and aware of the trade barrier due to the different in terms of the policy of gene editing. And here you can see here this the statements from the WTO, very clear, and I cannot agree more that the regulation of genome editing technique offer new opportunities for small, medium-sized enterprises and national research institutes. And this is how what we just mentioned. Also, Dr. William Dar, our chair, also mentioned that how can we make the research move the research to be on the plate or to the hungers. And so harmonization at national and international level should be ensure the potential of genome editing, for example. And ISF, International Seed Federation, also put their own communication, and they put that this is important of consistent science-based policy. So basically it just gives the benefit to everyone in the chains, like regulators, traders, brand bidders, consumers, farmers, academic institutions. If we have consistent policy, everyone win, for example. And so International Seed Federation, CropLife Asia, of course, Asia Pacific Seed Association, and I also believe APARI, because you are doing very good webinar series on this, just to make sure that the innovative technologies can be facilitated. And this is the view from our association and also our stakeholders. So from methodology point of view, these are traits that we obtain through gene editing technology for knockout, replacement of base pair, and some segment of insertion should be regulated as conventional breeding or non-GMO. And the final product approach also. So what we think is that how innovative technologies can be facilitated. Of course, we still need to discuss more, put our message to be heard more, or make sure that the scientists have the voice also, and policy regulators understand the science-based and risk-based when they want to put the policy in the country. And for us, ISF and APSA also put the position papers. In APSA, we also have position paper that is available on the website. The main statement is that plant varieties developed through the latest breeding methods should not be differentially regulated if they are similar or indistinguishable from varieties that could have been produced through earlier breeding methods. And yeah, I just would like to
please wind up quickly.
Yes, this is the last one. So the last one is I would like to say that in order to facilitate the trade, GM or new plant breeding tool is one of the focus. You can see this is the holistic approach, not only the policy for gene editing itself, it takes other harmonization system also as well to facilitate the seed. So yeah, that's all. I would like to conclude my presentation, and thank you very much for the opportunity.
Thank you for a very nice presentation. But the only thing is we've had a slightly longer inaugural, so I had to request you to.
No worries, no worries. I have the slide, presentation can be shared anyway.
Okay. Yeah. Thank you so much, May. We have our next speaker, Mr. Fabrice Mati. He is a patent attorney and co-head of the Rouse Patent Group, which has offices across the world. Mr. Fabrice is a patent attorney and partner with the IP law firm Rouse, where he co-manages the Global Patent Group. over 20 years of experience in patent protection and litigation in Southeast Asia, a member of the Standing Advisory Committee before the European Patent Office and a consultant to the World Intellectual Property Organization on Biodiversity. Fabrice is a researcher on climate science also at the University of Edinburgh Carbon Innovation Center. Right from the time we started planning this webinar series, intellectual property has been one of the major issues, which was raised by the participants to include in the webinar series. So we have Fabrice here, and then we will have Dr. Koo. Fabrice will tell us about understanding the IP landscape on gene editing, and then we will have a presentation from Dr. Koo, I'll introduce later on the strategies that we should adopt for accessing these patents. Over to you, Fabrice, and a special thanks to Fabrice. He is in Europe now and woke up very early morning for us to be part of this webinar. Thank you, Fabrice, and over to you.
Thank you very much, Dr. Vibha, and it's a great honor to be invited by APARI today to share my knowledge and experience in the field of IP or patent landscape in relation to gene crops editing. We start first with something that may sound quite obvious, but it's important to remind everybody that the plant innovation cycle is quite specific and different from the innovation cycle we may have in other industries, such as, for instance, the mobile phone industry. What makes plant innovation cycle so unique? It's the fact that actually it's very dependent on past innovation. So in other words, plant innovation build up on existing technology. And because it capitalized and built up on existing technology, it's very critical for researchers, for companies, for anyone involved in using plant innovation or doing plant innovation to be aware of what we call the intellectual property landscape. In other words, what is already protected, how those patents or IP rights are accessible or licensed, when those patents expire, because when they expire, they're no longer protected, and eventually you may be able to use them for free. So that's what I will try to highlight during my talk. But once again, there is a specificity in the plant innovation, the fact that it is building up on a lot of past technologies. And this is actually another slide comparing the different innovation cycle. The one highlighted in red is the one which I believe refer more to the plant innovation. You can see that some innovation cycle are slow paced one. So in other words, the innovation cycle is very time consuming. And therefore, when you reach, for instance, the innovation cycle number 3, you are not dependent on innovation cycle number 2 or innovation cycle number 1. But the one I mark in red, you can see that the innovation cycle are very subsequent and therefore very dependent on each other. Before discussing the patent landscaping in relation to crops in particular, it's very, I think, important to remember that patent is not the only protection available for crops. There are other IP tools, such as plant variety protection, but also trade secrets. We do have clients actually who come to visit our firm and say, we do not want to reveal our innovation. We want to keep it confidential because we are very concerned that if we disclose it, well, some people may copy it. And that's a possibility. You have major innovation that are still trade secrets. You also have plant variety protection. In some countries, it is possible to protect new plant varieties. In other words, plants that did not exist before and are the result of, for instance, gene editing activities. And of course, you have patent protection. Patent protection has a lot of advantages, but you also have major drawbacks. For instance, when you apply for patents, you need to disclose the product in details of the process of making the product. Therefore, you give an opportunity to your competitors to learn about your technology. And also patent protection is limited. It's usually 20 years protection. So once they expire, unless you do innovations such as improvements, your protection will no longer be enforceable and you cannot license it and therefore commercialize it. So this is a summary and I can answer any question later on. But what is very important that there is a consensus around the world that patent protection can apply to gene-edited crops, and that's great news. However, more recently, we have seen a tendency coming from Europe, which is a bit of a concern to us. The European Patent Office, which is one of the most distinguished patent offices in the world, has issued examination guidelines saying that if the technical feature of a particular plant, including gene-edited crops, might be the result of either a technical intervention. When I say technical intervention, it should be understood as human intervention. So a gene editing process done, let's say, by a lab. If that particular technical feature can be equally achieved through an essentially biological process, in other words, something occurring naturally, then the patents need to be disclaimed. What is disclaimed? It's an interesting legal concept where the owner of the patent acknowledges that he has no exclusive rights in a particular technical feature. And that's a big concern to us because, as Dr. May explained earlier, she said, well, genetically modified organism and gene edited are two different things, because gene edited is referring to a particular process which is not distinguishable from what happened naturally or essentially biological process, right? So here, the European Patent Office take the view that if the feature can be also achieved through an essentially biological process, you need to disclaim your exclusive right. So again, this is a concern to us. So in general, as I mentioned, you can apply for patents covering a modified DNA sequence through gene editing. It can cover the plant itself, so the final product, but also the process or the mechanism in order to achieve this particular gene-edited plant. And normally we recommend our patents, to our clients, to obtain protection for both the final product, the plant, but also for the process of making this gene-edited plant. So let's go now to the patent landscaping as such. This is a very summarized review of the 5 key cycles in patent management steps. First, we normally do with a client what we call a technology intelligence analysis. So we look at the innovation trends. We try to identify what sort of areas our clients could eventually invest, which are not too clouded in terms of patents. So therefore, there is room for the client to harvest and protect innovation in a sort of pioneer manner. And then second, we do what we call innovation capture. So we will try to harvest within our clients' innovation activities, what can be patentable? And then we move to the number 3, which is the risk assessment in relation to some invention we identify, whether we can actually secure protection. And then the 4th item is, once we got the patents, can we enforce against third parties or not who may want to copy because they are competitors? And finally, because patent is also something that you can earn revenue from, is how we commercialize, how we license. So this is basically a very short, brief summary of the life cycle of patent. Patent is not just about a piece of paper to say that you are a great inventor. It's a very much living organism to enforce and commercialize. So patent landscaping, as I say, part of this life cycle patent activities we provide to clients, very critical to identify what competitors, what people are doing, so we can protect our client from being sued for infringement, or we can eventually enforce our clients' right against people who are trying to copy their inventions. Or we can open the room for commercialization, as I say. This is for all gene editing fields, and not just crops, okay? So you can see that there are quite a lot of patents, about 10,000 so far, and the majority of the invention relate to improvement. This is very interesting because we're not dealing with breakthrough innovation, for instance. That happened very long time ago in the gene editing, back to 2012, something like that. But nowadays we see a lot of added innovation, as I mentioned earlier. You remember the subsequent innovation. So a lot of improvement built up on existing improvement. And you can see that the field of, for instance, medical technology, it's an important one, of course, but food is also, picking up as well. So you won't be surprised that 2 major countries are leading the field. And this is very interesting because that's echo what Dr. May referred earlier in her presentation by some research paper showing that US and China are very much leading the research industry. So here, top 10 applicants, mixture of companies, but also a lot of research or academic institutes, in particular from China. So again, that's for all gene editing fields. Let's be more focused on crops because this is exactly the topic of today. We see a massive increase in terms of patent filing. Look at, from 2015 to 2019, about almost 70%. And that's very significant in a patent areas. This is one of the fastest growing patent field together with artificial intelligence. Right? You may say, but what happened after 2019? Why such a decrease? It's normal. It's because patent takes about 20 months on average to be published. So we only get the data 24, 30 months after. So that's why at the moment we don't have clear data for part of 2020 and 2021. But if I make the same presentation in maybe 1 year, you will see that in 2020, we probably be at 250 and 2021 probably 350 applications. So, the growth is still very, very significant. Who are the major countries in terms of gene editing crops patents application? US and China are the country with the highest number of patents application and granted or registered patents, followed by Europe. But you can see what Europe is a bit behind because the European Patent Office has taken a view that is not supportive of the industry, unlike the US and China that are very much pro-gene edited innovations. And likewise, Canada, Brazil, Australia, India, Japan, Korea, Mexico have also, been quite active in terms of gene editing crops. And likewise, on the regulatory aspects, which is not my topic, but if you look at how gene edited crops are assessed in terms of risk and biosafety activities, well, Canada supports gene edited, Brazil, of course, Australia as well. India is considering, Japan, as very much on its own legislation dealing with gene edited as well. So I'm not surprised to see that the country that treat gene edited crops separately from genetically modified organisms win more patent application than the country that, I would say, almost discriminate gene edited crop by grouping them with gene modified organism. Few slides before I finish. The top filers in terms of gene edited crops, patents, you can see major US company, but also interestingly, China Agricultural University. So as I mentioned to you earlier, in China, the research is very much driven by the world of academic, while in US, we have more, I would say, a role played by the corporation. Inventors, and that's also very, critical to distinguish between applicants, the people or company that own the patents, and the inventors who create. Sometimes the inventor is not necessarily the applicant of the patent, right? He may sell his invention. So you see some names here that are becoming quite, regularly cited as inventors, and they are repeated for good reason, because sometimes they are people who have been active in a process. A way of making something, or a product, the final product. And you can see names look like more Americans and or Chinese. And that's also important to see that we have the same spread between US and China in terms of inventors, and not just in terms of owner of the patent. Finally, my last slide here is about what we call the clusters. We have heard the term clusters in relation to COVID, unfortunately, but the term clusters is more in a patent field in terms of islands or particular fields that are very clouded in terms of patent filings. So areas where we tell our clients, wow, there are a lot of competitors doing stuff, so that may be interesting for you to look at what they're doing. Or some clients want to stay away because they see it's too complicated to monopolize any rights, to privatize any inventions. So here is a very, quick and summarized snapshot, but you can see that main technology are selectable marker. There's a lot of activities, a lot of patent filing here, targeted mutation, and inducible promoter as well. So again, I cannot answer any more questions, but this is what patent landscaping can help. And you can pick up a particular areas, for instance, selectable marker, and go deeper if you want to, what sort of marker and so on. So this is the end of my presentation. I'm very grateful again to APARI for the opportunity, and I will be taking on any questions. Thank you very much, Dr. Viva.
Thank you, Fabrice. So nice, so much thank you that you presented a very nice landscape in terms of the patents, the clusters, and the technology. I am sure there are going to be a lot of questions, and we will get back to you on them. But before I move on to the panel discussion, we have to, can you unshare your slide, Fabrice? Unshare your slideshow.
Yes, so how do I do that?
So we have a small poll, 2 questions, which I would request all the participants to kindly respond to. Dilip, can you upload the questions? Yes. So this is a small poll which we have been doing in each webinar, and today morning we heard about the patents and about the harmonization of policies. So I will just put these questions, read this, and request you to respond. In the light of advances in the gene editing protected through patents globally, as we just heard from Fabrice, which of the following activities would require licensing from the patent holders? Undertaking research, publish papers, conducting experiments for educational purposes, or commercialization products through gene editing. You have to just tick one of the choice. Which of the following is likely to happen through harmonization of policies? Select all, this is repeated, sorry, select the one that does not apply. Out of the 4 which does not apply, kindly tick that. We will give about 30 seconds. I'll just repeat because my colleagues have typed both. Sorry for that. Select the one that does not apply, single choice. Reduction of disparities across countries, reduction of regulatory burden on national governments, access to genetic resources within our country, within other countries, facilitation of trade within regions. So one that does not apply may kindly be ticked. So we can close the poll maybe. Dilip? Thank you so much. And now we will move on to the panel discussion. As we mentioned, we have experts from 4 different countries in the Asia Pacific region in our panel discussion. And we have from Taiwan, South Korea, Japan, and Thailand. Our first panelist is Dr. Roland, head of the Molecular Genetics Flagship Program Leader, Vegetable Diversity and Improvement from World Vegetable Center, Taiwan. Dr. Roland received a PhD in Biochemical Technology from the Technical University Vienna and MSc in Molecular Biology from Austria. He's been with the World Vegetable Center since 2010 as head of the Molecular Genetics and now leading the flagship Vegetable Diversity and Improvement Program since 2017. His research interest is to mobilize vegetable diversity for breeding improved varieties that are accepted by farmers and consumers alike. So over to you, Dr. Roland. Dr. Roland is also a member of our steering committee and has been very, very supportive of this initiative. A short presentation, sir, as your views on the legal situation.
Thank you very much, Dr. Vipa. You should be able to hear me and to see my screen. If this is not the case, yes, please let me know. Yes. Thank you very much for inviting me to this very interesting webinar as a panelist. So a few words about vegetables and about enabling policies for genome editing from the view of vegetables. Vegetables because I'm coming from the World Vegetable Center. So just very briefly to vegetables. We like vegetables because they're nutritious. Some of us also like the taste of vegetables, and farmers like vegetables because vegetables generate generally more income than other crops. But with vegetables, we have a very specific problem. About a third of the harvest never reaches the consumers. And this gives a certain handle also for genome editing to improve this situation. So genome editing for vegetables, what can we do? Just very briefly, because this has been mentioned already so many times. We can develop new traits and we can apply new breeding technologies. And all that for 3 major goals. Probably there are more, but just I wanted to highlight 3 of them. We can improve the resilience of the crop by making the crop more tolerant to biotic and abiotic stresses and to improve the resource use efficiency. We can improve the product quality. Here we can think of nutritional value, taste, color, texture, and when it comes to vegetables, specifically also convenience. Convenience, I mean that vegetables or fruits now are more and more offered in supermarkets in cut or half-prepared state. And here the improvement of the quality through genome editing can improve these products. And then, as I mentioned already, reducing waste, reducing post-harvest losses, and increasing shelf life. Just very briefly, a few targets that we can have in mind for improving shelf life would be to manipulate ethylene production, to manipulate the resistance to fungal rots, to manipulate the fruit cuticle in order to make the fruits of certain vegetables more resistant during storage and to reduce fruits of them. And we like CRISPR technology for doing this because CRISPR is a breakthrough technology. It is not the real start for genome editing because sequence-specific nucleases before have provided this handle already, but CRISPR is just more easy to apply. And CRISPR is also said to be democratic. It's perhaps not really true that an average civilian can do CRISPR in the garage just when he or she is getting hold of a CRISPR kit, but it's almost like that. So when it comes to enabling policies for CRISPR for vegetables, we have to consider 4 items at least. We have to consider the genome editing regulation. We have to consider intellectual property rights, markets, and social acceptance. The upper 2 topics were already highlighted in an excellent manner this morning by Dr. May and by Dr. Fabrice. So I will shorten this part very strongly, and I will mostly focus on social acceptance. But when we talk about policies and regulations that should facilitate or should allow the use of the technology, we have to look at these policies along the whole innovation pipeline. This starts with a research idea that is generated during research and development. Then it requires access to information. Not only access to patent information, also in this case, access to sequence information, for example. And the access to digital sequence information, which is now discussed internationally, is a very important issue. And then the policies in the economic and in the social context are crucial for the uptake of any innovation, specifically for innovation in the food field. I do not want to spend much time about the legal aspects of CRISPR and CRISPR of vegetables. This has been already very well discussed by Dr. May. And also in the webinar last week, Professor McKenzie highlighted the different approaches of different countries when it comes to regulation of genome editing. Just want to mention that it is very important that as many countries as possible spearhead the movement to not focus on too much regulation of genome editing, because this will reduce the costs for approval, and it will also reduce the delays until the innovation can be taken up by users. Just very briefly to the patent landscape, because intellectual property is also one of the important factors to enable the use of this technology also on vegetables. Dr. Fabrice highlighted already the background in an excellent manner. I just wanted to show that the technology itself is regulated, as far as I understand it, and looking at this patent landscape, by 2 different patent conglomerates, if I may use this very unprofessional expression. On one hand, there is the Broad Institute with all the patent holders around it. And on the other hand, there is the University of California with all the patent holders around it. And these 2 entities are kind of fighting for having the bigger right about the technology. Important to note is that it seems that most of the patent holders are ready to grant non-exclusive but free licenses for research, specifically for the academic sector and for non-profit institutes. So the research is facilitated, but the problem comes when a product has to be commercialized. And Dr. Fabrice was highlighting already how complicated this can be. And I try to highlight this on this picture that illustrates the stream of vegetables, fruits, and ornamentals globally. And now imagine that everywhere you have a different regulation, legal regulation or IP regulation, which is affecting the flow of these products. This causes a lot of costs and a lot of losses on the way. So one keyword I wanted to throw in this context is open innovation. Open innovation does not mean open source. Still, intellectual properties are governed by patents. But recent experiences, especially in the pharmaceutical sector and the electronic sector, has shown that open innovation, in the sense that there is a transparent policy of intellectual property management in enterprises that allows the efficient sharing of intellectual property across enterprises and across entities. So a change of thinking that innovations are not produced in a silo, but innovations are produced in a creative space where a multitude of entities and even more creative people are working together to produce new things. Now, let me come to the social acceptance. Social acceptance of bioinnovations is crucial, and it decides about the success and the non-success of the technology. I just want to remember the BT eggplant story in India. A few thoughts how social acceptance could be increased for CRISPR of gene-edited crops and vegetables. First of all, I think the broad availability of the technology would stimulate the product development and the uptake. If there is just one owner of the technology or a few owners of the technology, that does not create an atmosphere where this technology is perceived as something very positive for mankind. Then, public goods generate early adopters. Oh, I don't know where this yellow and blue stripes are coming from. Somebody is making the slides more beautiful. These early adopters and the public goods, this idea is coming, I think, from the IP sector, innovation, from information technology sector, IT sector, where certain features of many developments are free. And other features, more sophisticated features, have to be paid for. These free features generate early adoption and better acceptance of products. Then the access of genome editing technology to small vegetable seed companies. Here, we generate opportunities for a multitude of crops, for a multitude of traits, for a multitude of market niches where these technology can be readily applied. If this is supported by the industry, then there will be more acceptance for this technology. Then it comes to the traits. If these traits are perceived to be traits that help farmers, that help consumers, if these are not uniquely traits that are helping the industry, acceptance will be accelerated. And most importantly, the commercial practices around genome editing should be perceived as fair. If these commercial practices are perceived as unfair, this might crush the social acceptance. I think we have experienced this in parts of the genetic engineering industry. Just one picture about the public acceptance of gene editing. There's not so much valid research around because there are not so many products available. So it is more or less a hypothetical question. If we ask the people, are you ready to accept genome edited foods, or are you not ready to accept genome edited foods? And it shows that different countries, different cultures respond very differently. And not surprisingly, in Europe, for example, here in Belgium and in France, the proportion of people rejecting genome editing for producing foods is quite high. The main barriers for the social acceptance are probably general concerns about food safety, and then I perceive an overall lack of willingness to accept food products derived from biotechnology of any kind. This is kind of a fundamentalistic rejection. And newer studies in Japan show that there is quite skepticism out there, also for genome editing. So we have to be very careful not to repeat the same mistakes we made when we were introducing genetic modification in food production. And now to my last slide, a few thoughts how developing countries, how low-income countries could develop strategies to make genome editing as useful as possible. So what could governments or national research institutions do? First of all, I think we need to ignore European attitudes and markets. This is a different story. We should not take this example. And then we should seize those opportunities of gene-edited crops that would benefit most the local farmers and the consumers. And then work on traits that address societal and climate challenges. A few points what the industry could do to contribute to a broader use and broader acceptance of genome editing. First of all, they could support more non-government, non-profit organizations, academic organizations, and NARS, especially in low-income countries, to access the technology, to develop products, and to market them. And then to have a culture of honest and science-based public debate of genome editing. Then it should be our job also to provide food products with equitable outcomes to protect the environment and also to have positive social impact. And very important for the industry, the public should perceive that there is a balance between shareholder and stakeholder interests. It should not be just earning money. It should also be think at a little bit longer term, what a technology will achieve in the long run. And then what could be the role of international organizations in increasing the acceptance of genome-edited foods. One thing is to work on the international harmonization of agricultural biotechnology regulation. We have heard about that in the foregoing talks. And then develop public goods using this technology and show how beneficial this technology can be for farmers and for consumers. With this, I would like to thank you for your attention. Thank you very much for inviting me.
Thank you, sir. Thank you, Dr. Roland, for giving overall approach for ensuring the requirement of enabling policies for the vegetables particularly, and generally to all the gene-edited crops. My next panelist is Dr. Okji Koo. Dr. Okji Koo is the Director of Plant and Animal Genome Editing Division in the Korea-based CRISPR-Cas9 company, ToolGen, a real practitioner for the implementing the technology for the commercial purposes. Dr. Koo obtained DVM and PhD degrees from Seoul National University, Korea. During his career, he has focused on generating various transgenic or genome-edited animals using various molecular tools such as zinc finger nucleases, TALENs, CRISPR, etc. And after joining ToolGen, he's also been involved in the crop projects, genome-edited projects, crop projects, where like high oleic acid soybean, pale purplish pink colored petunia. He's co-founded an agriculture technology startup, Plant Edit, based on DNA-free genome editing technology, and is currently working on genome editing in hemp and microalgae. I've had a long association with Dr. Koo and very looking forward to his presentation on strategies for commercialization gene crops. Over to you, Dr. Koo, and thank you for taking out time. He is extremely busy and we really appreciate your taking out time. Thank you.
Thank you very much for the kind introductions, and I'm really appreciate that Dr. Ho Min Chang and all the members of this committee to inviting me to this wonderful webinar series. So hello everyone, this is Okji Koo, and I work for the Korea-based CRISPR company named ToolGen, and ToolGen is actually mainly focused on the developing human therapeutics, but we also have some project for developing the genome-edited crop. And based on the experience from my company ToolGen, I also co-founded the genome-edited crop company. It's a startup in Ireland, the name the Plant Edit. So actually today the other speaker, the Fabrice already explained the very nice presentation and giving you the very informative information about the patent in the genome edited crop field. But today I'm going to show you and share you my personal experience and the idea to some little bit practical view of how we can get the CRISPR-Cas9 the IP right for the commercialization. So, oops, sorry. Okay, so today I will show you a series of the cases and I try to explain in this case what you need, and then the other case what you need. So in case one, we're thinking about you are the students who are the professor in the university, or you are work for the non-profit organization or government-oriented institute. In that case, you want to doing some research using the CRISPR-Cas systems, then actually it is quite similar to the today's poll question number 1, but in this case, I'm pretty sure that you don't need any CRISPR-Cas IP, and you can freely use the CRISPR system for your research. You can develop anything based on the CRISPR, and maybe you can make another patent about the new technology for enhancing the generation of the GE crops, or yes, you can develop the new trait from the plant of your interest using the CRISPR-Cas9 systems. But sorry, so in some cases you are maybe thinking about licensing out your new invention, like a new technique for G generation, or your new genomic crop you want to licensing out to the company. So even in this case, you might get some benefit, but you still no need to getting the right for the CRISPR-Cas9, because what you are doing is the research and development. But if you're licensing out the technology, actually the company, the licensing in your technology, they actually need the CRISPR-Cas9 IP for commercialization of your product. Okay. But in case, even though I explained that you don't need any CRISPR-Cas IP for your internal research in the academia or the non-profit organization, you still may think that you need some official right or something for your own research. Then maybe you can thinking about to contact Merck and the Broad Institute. Actually, Merck is a Sigma Aldrich, and they are actually now the subsidiary of the Merck. So these two institutes built some CRISPR co-licensing framework, and if you are working at the academia or non-profit organization, they can provide royalty-free research IP for your research. So you can contact them to get some official research license from them. So this is the case number 2. So actually, if you are already developed something using the CRISPR-Cas9, I should note that it is the Cas9, not other CRISPR-Cas system. So anyway, if you develop something already using the CRISPR-Cas9 and you want to start a company based on the developed product, then you should need the CRISPR IP for commercializing your product, even though the product is developed by you. So in this case, because you using the CRISPR-Cas9 for your research, you should think about many things. So actually in the webinar 1, Dr. Hiroshi Ejura already mentioned that because he is actually starting his company Sanatec Seed, and he's a very honorably the commercialized the world's first the CRISPR-based genome edited crops. But in his presentation, he mentioned that he can get the CRISPR-Cas9 IP from the Corteva. Corteva is formerly a DuPont Pioneer, and now the name is changed to the Corteva. So he mentioned that he can get all 3 fundamental CRISPR IP from the Corteva, and he also mentioned that the price is actually reasonable. And actually, I'm mostly agreed with Dr. Hiroshi Ejura. However, actually, the situation is a little more complex. Actually, in 2012, not only the Vilnius University or the UC Berkeley, actually, the UC Berkeley IPs that comes from the Nobel Prize, the Jennifer Doudna and the Emmanuel Charpentier, and also the Broad Institute. These 3 is regarded as a major IP in the CRISPR-Cas9 field, but actually our company Toolgen and the Sigma Aldrich also filed the fundamental CRISPR-Cas9 IP in the 2012. So even though the Corteva is, they are actually exclusively licensing in these two CRISPR-Cas9 IP for the agricultural use, and the company of the Corteva and the Broad Institute made the joint licensing program, and you can contact the Corteva to get all of these three major IP. In some cases, you still need to licensing in the IP from the Toolgen or the Sigma Aldrich. So actually, the situation is very complex because maybe if you are already did the IP filing or any official action or IP for your own invention, you might understand this very clearly. But even though the same IPs are filed in each country, maybe the granted IP claims are slightly different from each country. So if you really want to commercialize your product based on the CRISPR-Cas9 technology, you should think about and decide the target market first, and you should research on what claims are granted in each country. So if you want to commercialize your product in China, this is granted IP that the CBC and the Broad Institute and the Sigma is granted their CRISPR-Cas9 IP in China. However, the granted claims are literally a little bit different, so you should download the claim sets and maybe you do see what you need to licensing in. And actually, because this is the webinar series for the regulation policy, if you want to commercialize, so if you want to commercialize your product, not only the patent issue, but you also considering about the regulation policy of each country. So if you want to commercialize in China, even though you already have the CRISPR-Cas9 IP from the CBC, Broad Institute, and the Sigma, if it is not feasible to commercialization yet because the regulation policy is not established. So it is very important for the company that the clear regulation policy is set up so quickly and the fasten up the commercialization of all the innovative product. So the case number 3, it is the rest one, and actually I have to mention that even though I work for the CRISPR-Cas9 company, but I have to mention that there are the alternative CRISPR-Cas systems out there. So something like a CPF1, it is now called a CRISPR-Cas12a1, and the other CRISPR system like a MED7 or the CMS1, and very recently the other system like a Cas-X and Cas-Y comes out, and also very small Cas-Pi systems are also validated. So if you are not have any product made with the CRISPR-Cas9 yet, and you have a great idea, innovative idea, and you want to start a company, or you are already working with a small company who want to developing a new crops based on the CRISPR technology, maybe you can considering this Cas alternative for your research, because the IP situation of this Cas alternative is much simpler, so it is quite easy to licensing in. And very interestingly, in case of the MED7, it is actually owned by the US company named Inscripta, and actually they mentioned that in their website that they will not charge any royalty for using the MED7 enzyme, except several cases. And I already see their website, and in my opinion, the genome edited crop is not do not need to paying loyalty to the Inscripta. So maybe if you are thinking about the startup, or if you want to starting the commercializing any product, then maybe you can thinking about this new CRISPR-Cas enzyme for development of your product. And recently I saw at least 5 or 6 startup companies started with the medicine enzyme-based technologies. Yeah, so I think this is my last slide, and it is captured from the webinar 2. The webinar 2, the Dr. I'm sorry, I forgot the name. Peter Tageson. Yeah, yeah. Peter mentioned that the gene-edited product, and actually this morning the May also mentioned that same thing. And actually, the genome-edited product is the more suitable for the local and the small to middle-sized company. So I'm pretty sure that these technologies can provide the huge benefit to the Asian Pacific countries and the very young and the innovative scientists in this field. For they can start a new company and they make the economical value in the Asian Pacific area. So as I mentioned before, not only patent issue, but also the policy of the genome-edited crop is really important for facilitating the commercialization of this innovative genome editing technology. So I'm really hope that some good and clear policy will be set it up quickly and help us to innovate the whole field. Thank you very much.
Thank you. Thank you so much, Dr. Koo. I'm sure our participants have been greatly benefited by this, because the strategies to access this and take forward their research to the society is very, very important. And this IP is the most important component. Thank you so much. And can you unshare your screen? And I will move on to our next panelist, Dr. Masahi Tachikawa. Dr. Masahi has been working with the Japanese Ministry of Agriculture, Forestry and Fisheries for more than 20 years. He joined the Graduate School of Environmental Studies, Nagoya University, Japan. He's presently there. His major is sociology and STS, which is the Science Technology for Society. Dr. Tachikawa has been watching at the regulatory system of biotechnology and other emerging technologies and their implications to the food system and society as a whole. He's published several books and journal articles, mainly focusing on the GM as well as gene-edited crops from a social science viewpoint. So we will hear from Sir about the public perception of genome-edited egg food products in Japan. Over to you, Dr. Masahi.
Yeah. Thank you so much. Thank you very much for inviting me for this very interesting and very precious seminar. And thank you also. Thank you so much. I really appreciate organizing committee. So my topic is because it's time constraint. I just focus on public perception issues, gene-edited products in Japan. So my group did a survey for a couple of years, maybe at least 3 times in a row. So first survey was done in December 26, and the latest survey was done in last year. So I like to present a little bit result of this web-based questionnaire survey. So this is the kind of the result of how the consumers acknowledge the benefit of gene-edited product and compare with research and consumers. Overall support from both consumers and researchers can be observed, because this is, as you can see, this is beneficial to food supply and beneficial to human health and beneficial to economy. And most of us consumers are very supportive to the gene-edited product, but the researchers are more and more supportive to compare with these consumers. So this slide shows the perception of gene editing related to safety concerns. So maybe you can see this bar chart main remain safety issues and may have unintended effect. So some consumers still they have some maybe uncertainty feeling, some concerns about the gene-edited product compared with researchers. So, and this slide shows the, so maybe you can see the this bar chart. So some respondents express their feeling, so they cannot understand where, and some were fearful. So this maybe this part shows the majority of consumers don't have the familiarity of these techniques. So still they don't understand and feel uncertainty. So this is a kind of the how they should be regulated, and such as zero risk approach or scientifically appropriate manner or minimum regulation or even no need to regulate. So maybe this is the gene edited product. Consumers prefer zero risk approach is desirable compared with scientifically appropriate manner for researchers. So consumers prefer strict regulation over genome editing. So this result is in 2016, but there's almost same result we got in 2020 survey. Here is a labeling issue. So to our surprise, so most of the consumers and many researchers prefer to have the labeling, kind of mandatory labeling over the gene-edited product. In case of consumers, more than 60%, and the researchers is more than 40% of respondents prefer to have kind of the mandatory labeling. And in 2020 survey, also we had 61% of consumers chose all products need labeled. So almost same. So after 2 years later, in 2018 survey, we compared plant with animals. So, maybe we pick up several traits like taste better or nutritious or disease resistant, or make their plant or animal size increase. And the consumers find concerns about changing size of animals and the lesser degree of plant. So maybe you can see that this is livestock and this part is a vegetable. So, and this is the blue part is opposing attitude. So increasing size of livestock by 50% or by 20%, they are many people are opposing this kind of application. But in case of the vegetable or other applications like maybe taste or nutritional value, so their opposition is very small. And this is kind of experimental setting for the surveys. If you show the respondent, so the image of the animal or plant, the result tend to be different. So consumers tend to respond differently when they are shown plant product like tomato or animal product, such as pig, as an example of gene editing. So this is bioethically questionable. So in case if you show the animal, maybe the ethical issue was raised, and they tend to be respond negatively against the gene-edited product. So in other words, different responses comes out. Depends on the questionnaires, such as the maybe unexpected adverse effect or misusing technology or bioethical issue or labeling issues. So maybe if taking BIC as an example of gene edited product makes consumers feel uncomfortable. So if you design the web survey, so the tomato and pig makes result differently. This is a kind of interesting finding for us. So this is a summary. In general, Japanese consumers tend to be supportive to gene editing in agriculture and food, but consumers prefer to have strict regulation and labeling on gene-edited product. And consumers feel somewhat fearful, and maybe because of difficulty to understand the technique. And application to plant and animal may lead to different responses from consumers. This is a kind of interesting issue so for researchers. Thank you so much. So maybe if you like to read our studies, maybe those are references which my group is doing the results based on these questionnaire surveys. Thank you so much.
Thank you, sir. Thank you, Doctor, for also sharing these publications. I'm sure our participants can have a detailed look at the methodology adopted and the observations if they wish to replicate similar surveys in their own countries. Moving on, I would like to now invite Dr. Ravi Khetarpal, whom you've already heard in the morning as the Executive Secretary APARI since 2017. Dr. Khetarpal has been very active in the area of biosecurity, biosafety, seed certification, and biodiversity. And his areas of interest include research development, policy issues, and capacity building. Dr. Khetarpal served before joining APARI. He's been the regional director of CABI South Asia and also its regional advisor on strategic science partnerships over a period of 7 years. Prior to that, he worked for the National Agriculture Research System in India for almost 3 decades. He has PhD in Life Sciences Virology from the University of Paris and has been a visiting scientist in an EU collaborative project at INRA in France. Dr. Khetarpal will share his views on the need for enabling policies, particularly on the harmonization aspect. Dr. Khetarpal, sir.
Thank you, Dr. Vibha. Thank you so much. Well, being the last speaker of the day, and when the time is just over, it's the time when we have to close the webinar, it becomes quite challenging for me to make my point. Anyway, I'll begin with some very basic points. I'll try to be brief. I will avoid all the things which have been said by all the distinguished speakers, panelists. What I see clearly here is the public and environmental safety, and on one hand, and public perception and expectation on the other hand. They are always under a tense kind of a situation for a regulator. He has to take care of safety, he has to take care of perception and expectation. That is something we have to keep in mind when we move ahead in the policy. And secondly, when we move ahead in the policy, we generally cannot keep pace with the fast moving scientific advances. And we immediately want a policy once you have a scientific advance. So these are some basic issues globally. Now, this genome editing has evoked enthusiasm we all have seen over 3 webinars, but also controversies, creating regulatory and governance challenges, as has been presented by almost all the speakers. Right now, many countries are in the process of developing regulatory approaches, so the opportunity remains high for an enhanced global regulatory coordination. However, to look at things at a global level is not very simple. I will just make a PowerPoint presentation here. Just 1 second, please. Yeah, okay. Anyway, I'm not able to project it. That's okay. But when you look at this scenario at the global level, it is quite clear that genome-edited crops are regulated as GMOs in number of countries, such as in the European Union and in New Zealand. Genome-edited crops are non-regulated as GMOs, especially if no foreign DNA, they're not regulated as GMO in Australia and in Japan within the Asian scenario. And there's a different scenario in Canada where not regulated unless trait identified as novel. Then there are places like in US where we have most non-transgenic plants are not regulated. Then in South America, we have a situation case by case. And also in Paraguay, Nigeria, things are coming up now case by case. In Asia, India and Philippines, discussions are ongoing, and GMO definition encompasses the genome editing in the case of India. So we have a clear diagnostics of the situation now. Well, if we come to the clear picture of what has been said by all the speakers, we will see very clearly that there's a concept of opinion of imposing regulatory scrutiny based on the documented risk of the product rather than on the process used to breed them. And this has come up in the discussion quite clearly. Now, going back to the Europe EU situation, I think Dr. Roland highlighted very much. We don't need to really look at that. And even within EU, German science academies and German Research Foundation concluded that due to mounting divergence between scientific progress and legal standardization, the process-based European regulatory approach is not at all justifiable. And they also mentioned that is within from Europe, that potential risk can only come out or emanate from the modified traits of the organism as a product of the breeding process and not from the process itself. So there are cases which we have not to look at because there is a sense of, if you know the international trade norms of WTO and other norms, you will see there is a clause everywhere called precautionary principle. And if you look at the EU case, there is a pure case of politicization of the precautionary principle. Precautionary principle is you cannot accept import, you can be free to reject an import if you are not satisfied with the technical details or the technical justification. This is actually characterized in the EU more by fear than by expertise. And with the view that it can help for Europe to world trade, you can see how genetic engineering legislation is abused as an argument for avoidance and instrument. I'm not going to speak much on this, but the controversial debate with EU and other global countries as it comes to how to regulate genome-edited plant has finally given us two opposing school of thoughts. Number one, those who consider genome-edited plant of low or negligible risk and agree for no or less regulation. That's what we have seen with most of the countries in all representation. And those who highlight uncertainties and knowledge gaps and ask for same or similar regulations as for GMOs. Now, with this background, looking at the time frame, I have something to discuss, but I'm going to give up on that. I can share my write-up, in fact, with you people after the webinar. I will come to some major conclusions, looking at the time available with us. Number one, many countries in Asia Pacific, where we are trying to bring a kind of a harmonized approach through all this exercise, Many countries here are still in the process of developing regulatory approaches for products of genome-edited plants. So the opportunity remains very high for enhancing at least our regional regulatory coordination to begin with. Now, when you look at WTO, there's a presentation in the morning that there's a discussion in the SPS Committee for Deregulation of Genome-Edited Plants. But I think that was at a very casual level. It really needs to be discussed more and make it happen. However, WTO is very important for global trade. But let me tell that we should not stop the way we are working, the way we are developing our own policies, because there is always for trade a scope for bilateral agreements. We can have a mutual recognition clause evoked between two countries if both of them have a similar approach or a similar kind of understanding on a given policy. So this is something we should keep in mind, the mutual recognition clause under WTO, where trade will not stop, but you need to find the right partners. Then regional harmonization is of course necessary to have a global coordination. And it is actually very important that innovative technologies such as this genome editing are supported by modern legislation. It is obligatory, in fact. And with the awareness, what we are bringing through our publications, which will be coming up, with the discussions we are having, and with the right communication, which we will bring up with the policymakers to a high-level policy dialogue at the after we have our document ready, we are quite hopeful that we will be able to have the proper articulation of risk in crucial, which is very crucial in the crucial agreements or global things like the Cartagena Protocol, SPS agreement, Convention on Biological Diversity. How you articulate your risk everywhere is very important. And that is where the communication will become very important. And with the kind of expertise we have, we are sure we are going in the right direction to have an enabling policy for the Asia-Pacific region by also telling them that nothing to be disheartened if there is no global coordination. We can always have a regional approach, but it is important to identify a right partner for trade as far as trade is concerned. And we are quite sure we will be going for such a harmonization in the coming times. Thank you, one and all. You are on mute, Dr. Vibha.
Sorry, sir. Thank you so much, everyone, all the panelists for their very interesting presentations. Normally we have just the discussions, but these topics required that we have slide shares for better understanding. And there have been questions from the participants, but I'm really thankful to the panelists that they are answering right there and to this one. So I request everyone to keep looking at the chat box. And if you have any questions, we can answer that. Otherwise, all these presentations will be available on the YouTube. You can always interact with us for any questions, and we'll put you in touch with our speakers and the panelists. Moving on, we have the next item as concluding remarks. And as I said in the opening session itself, that while opening the webinar, that we've had guidance from a very, very supportive steering committee. And we have members of the steering committee also attending all our webinars and giving us guidance all through on how to move forward. And in fact, I would like to invite Dr. Kiran Sharma, who is our member of the steering committee and has been very, very supportive to this whole activity. Just to introduce Dr. Kiran Sharma, he is the team leader of the Agribusiness and Innovation Platform and principal scientist cell biology at ICRISAT. ICRISAT had also, as we mentioned earlier, ICRISAT and APARI had organized a similar initiative in 2019 after the second Asia Forum on Gene Editing in Seoul. And these two events were actually laid the platform for giving us this idea to take forward. Dr. Kiran has a very distinguished academic career with PhD from University of Delhi and postdoc from University of Calgary in Canada. He has over 25-year experience in genetic engineering and molecular biology, published over 150 publications. In addition to the academics, he has been a pioneer for public-private sector partnerships and entrepreneurship development in India, having established the platform for translational research in transgenic crops in ICRISAT in 2007, which facilitates the translation of the genetic engineering techniques, and also played a very key role in establishing an agribusiness incubator at ICRISAT in 2003. Over to Dr. Kiran for his concluding remarks and a bit of way forward as he views from the steering committee perspective. Over to you, sir.
Thanks a lot, Vibha. I think thanks for the introduction, and it's my privilege to give this closing remarks. I really thank Dr. William Dar for agreeing to be part of this and sparing his time and providing his stimulating remarks. Unfortunately, he could not stay with us due to other pressing commitments, which is understandable for a person at his level. Thanks also to all the speakers and panelists of this session for sharing their thoughts, which has been very useful. With this, with final webinar on enabling policies for genome editing in agriculture, we have come to an end of this very exciting webinar series organized by APARI, APCOIB, BCIL, and Korea Biosafety Clearinghouse. So overall, I think if you look at all the webinars, it's very clear that each crop has intractable problems that are not easily solved by traditional plant breeding. Hence, integration of advanced breeding methodologies in a modernized breeding strategy is very pertinent to filling in specific gaps for delivering high yielding, nutritious, and climate resilient crop varieties. The availability of reference genomes and ever increasing resequencing data has significantly advanced breeding applications, and to capture the genomic diversity and effectively mining it going forward with genome editing. Gene editing enables the use of this enormous genetic diversity present in wild species or uncultured varieties of crops as a source of allele mining, potentially expanding the crop germplasm pool. Additionally, direct improvement of elite varieties by genome editing does not really introduce potentially deleterious alleles from crossing and recombination. That has proven scientifically. Moreover, due to the multiplexing ability now, multiple target genes can be modified simultaneously in a very efficient way, thereby enabling immediate pyramiding of multiple beneficial traits into an elite background within 1 or 2 generations. So several important advances have already occurred in crop breeding, and what we see today is only the tip of the iceberg. Much more exciting avenues are yet to unfold, and a technology like genome editing needs to be fully explored and exploited. Regulation of breeding products follow 2 frameworks. What we have seen so far, some countries regulate the process, while others regulate characteristics of the final product. This has been very clear from all the presentations we have had so far. While some countries have established biosafety regulations for genome edited crops or already have declared their regulation, their deregulation, several others are working around their regulatory positions, and hopefully we soon will have a much more harmonious regulatory framework around the globe. Inconsistency in regulating products of plant varieties developed through gene editing methods is a major challenge for its adoption in global crop improvement programs. Hence, there is an urgent need to deliberate on science-based, predictable, and proportionate regulations with clear timelines to encourage innovations in food and agricultural production systems. While a number of major agricultural countries they have deregulated or not regulating SDN1 and SDN2 category of genome edited crops at par with the GMOs, Several others are still discussing the regulatory landscapes, and I hope this happens soon, sooner than later. This also brings us to the point of harmonization of the international regulatory systems so that the disparities across countries may be reduced. Reducing regulatory burden on national governments and on the broader community of users can facilitate technology deployment and trade within and across regions, thereby providing new solutions to some of the intractable traits and constraints for sustainable agriculture. There is a need to focus on corporate strategic behavior as well, such as technical collaborations and acquisitions of public-private partnerships. CGIAR and other international institutions are committed to forge new partnerships and create incentives for changing the innovation climate across the national, regional, and global research ecosystems. Not only such partnerships build technical capabilities within developing countries, the NARS, it also ensures public sector capacity to negotiate intellectual property and licenses in order to secure freedom to operate and technology deployment to farmers. Hence, appropriate public good licensing agreements are necessary to make sure that smaller seed companies and other seed value chain actors can get access to improved technologies. We also are looking at open innovation opportunities here so that everyone can have access to such technologies. There's also need for capacity building and greater efficiency along the whole seed value chain. That includes the CGIAR centers, the NARS, seed companies, and seed trade associations, extension services, regulatory agencies, non-government organizations, and social entrepreneurs, all the way down to the farmer groups. Finally, the societal concerns about genome editing stem in part from the lack of information about its principles and applications in food and agriculture, as well as other aspects related to regulations, trade, and commerce. So this webinar series was an effort to share the knowledge on the principles of genome editing, its applications in food and agriculture, as well as other aspects related to regulations, trade, and commerce. And I think those objectives were very well met, and we look forward to the APARI documentation, which will provide an important resource to all the people working in this area. So this is an exciting time with new technologies to accelerate breeding and innovations continuing to be made. Let us hope that it will not be long before these developments create new revolution in agriculture. I thank all the participants of this and previous webinars. I wish you all the best in your endeavors towards ensuring that this unique technology can provide the intended benefits to humanity, especially under the climate change and environmental degradation scenarios. So I'll stop here. Thanks and have a good day, and look forward to continuing such interactions in the near future as well. So thanks, and back to you, Vibha.
Thank you so much, sir. Thank you for very encouraging words. And we also look forward to preparation of the resource document. We have very distinguished authors identified already, and we would be now working with them to ensure that a very useful resource document for the region is in place to guide everyone. With this, I would hand over to Dr. Rishi Tyagi, who is the co-convener for this whole activity along with me. Dr. Rishi Tyagi and I have been working together for put this thing all together. And over to you, Dr. Tyagi, for the final words.
Thank you, Dr. Vibha. We have come to end of this series of webinar, as well as the webinar 3, which is very important, enabling policy for genome editing in agriculture. It's my pleasant duty to propose the vote of thanks, formal vote of thanks. And first of all, I thank Dr. William Dar, Secretary, Department of Agriculture, Philippines, who made his presence out of his busy schedules. We know that he has been very busy with the government affairs. Nevertheless, he gave the very encouraging opening remarks during his presence. And in absentia, thank you, Dr. William Dar. for starting this webinar. Though we could not get benefit for your presence throughout the webinar, still I think participants and everyone is satisfied by your presence in the morning. My thanks goes to Dr. May Choi, who is the Executive Director, Asia and Pacific Seed Association, commonly known as APSA in Thailand, for making a presentation on need for harmonized policy on research, utilization, and trade of genome editing plants. And Dr. May, I can assure on the behalf of the participants, your presentation was very well accepted and heard with the great interest by the participants, as we are getting the feedback in the chat box. So thank you so much for making the important presentation on this aspect. Now, my thanks to Fabrice Matti, patent attorney and co-head of Rose's patent group. In fact, I want to place on the record that we contacted Fabrice very kind of SOS time, because one of the speaker could not make it because of certain problem with him at the 11th hour. So we contacted Fabrice and he readily agreed. In fact, within 5 minutes, I sent the message and he agreed to make a presentation. Fabrice, really, we are very thankful to you for making presentation at very short notice and covering the excellent overview of the patent of the IPR-led landscape in the gene editing. Thank you, Fabrice. My thanks, sincere thanks goes to all the panelists. I would like to name Dr. Roland from World Vegetable Center, Dr. Ku from Japan, Dr. Masai Tachikawa from Japan again, Naga University, Japan, who has made the very good presentation on the public acceptance and what Dr. Ravi has mentioned in his discussion as a panelist, that public acceptance is equally important as this technology had to move forward and get the benefit to the humanity. So this was an excellent presentation. And I thank Dr. Ravi for making not only the opening remarks, for making the discussion as a panelist, and also chairing the steering session, chairing the steering committee. In fact, the steering committee is guiding us for developing this whole document through this webinar series and having the chapters on different aspects. And I want to thank profusely the steering committee members all for their valuable guidance. And I see in here that Dr. Kiran Sharma is there, to whom you have heard just now. Dr. Norwati from Malaysia is also in the room. And Dr. Roland already has spoken about as a panelist today. So many other steering committee members, I would refrain to name everyone. They have been there from the global, they are the global expert in the genome editing and have been guiding us to take up this very important activity in the region. I thank the participants who have joined the 3 webinars, like Dr. Vibha mentioned earlier, that so much interest was generated that over 2,500 participants have registered from 70 countries. So we intended to have the webinar series targeting the Asia Pacific, but we are happy to see that the 70 countries have been benefited one way or the other by organizing these activities. And I'm sure that the discussion and the speakers who are the expert in this area have given their lectures or the talk or discussion, all the participants in the different countries have been benefited. So thanks to all the participants coming from the different countries and coming from the different zones to attend these webinars. My thanks goes to Dr. Vibha Ahuja, who is the Chief General Manager of BCIL, and Dilip and his team, who have been doing a lot of background work, contacting and corresponding with the different speakers and different panelists, to organize these 3 webinars. And I want to thank very profusely for the cooperation and collaboration with the Korea Biosafety Clearinghouse, South Korea. Dr. Ho-Min Jang has been there, and he has chaired one of the webinar, co-chaired one of the webinar, and he has agreed to generously contribute financially also to take up these activities and culminating into the resource document, what we are intending to release it in the high-level policy dialogue in future. I thank my own colleagues from APARI Secretariat for their contribution in one way or the other to conduct these webinar series very smoothly. And a lot of background work has been done by them. So thanks to all of them. And then finally, I want to thank again the steering committee, because we need their support and guidance again and again for developing this important document. If I have left some name, it is inadvertently done. But once again, I thank all, one and all, who have been associated with this these activities directly or indirectly. And before I stop, I have a request to all the participants to switch on their video so that we can capture group photographs for our record. And I request my colleague Jack, please quickly have few shots. Jack, you are there?
Yeah.
Okay.
So you may have to turn on your webcam. So we will have 2 pieces of group photo.
So while Jack is taking the pictures, sir, I just wanted to say that we all were thinking that this is the final webinar, but actually our series will continue when we come back to you all with the resource document and share the document with you. So we look forward to, participation of all at that time also, when we get back to you in about 2 months' time.
Thank you, ma'am.
So let's do the first one. 3, 2, 1. Okay. Wait a second. Let me save it. Let us do the second one. 3, 2, 1. Okay, thank you.
Thank you.
Thank you all.
Thank you, Jack. And as Dr. Vibha has mentioned, that we have your contact emails and addresses with us. We'll be informing you whenever we have this kind of activity, and we think your cooperation will always be there. And thank you so much. Have a good day.
With this, we will close the webinar. Thank you so much.
Bye-bye.
Thank you.
Thank you. Bye-bye.
Bye-bye.
Thank you.